Alright, hey, I'm back. This is the last homework, which feels pretty good because I'm kind of sick of making these videos. But alright, let's talk. So what you're supposed to understand here is that there's two kinds of special angles. There's an angle called the angle of elevation, which is where we're going to let this little kid here just look out horizontally. He's just looking straight. And then the angle of elevation is how the angle rotates up from straight like that to go off at an angle. That angle right there is what an angle of elevation is. It's an angle that rotates up. And before you ask, sure, there is a name for angles that go down. It's called an angle of depression. And again, you start by establishing what a horizontal line would look like, and then you figure out how your angle must have moved. Our angle of depression must have started looking straight out, but then it gets drawn down. So this is the lifeguard's angle of depression toward the swimmer. But that's it. There's angles of elevation, angles of depression. And let's do some practice problems. Number 1 says that Casey sights the top of an 84-foot tall lighthouse. And if Casey is 6 feet tall, then how far is he standing from the base? So this is kind of tricky because you basically have to imagine that there's a rectangle and everything's sort of happening on top of this rectangle. So out here, out to the top of the lighthouse, which I'll assume is here, I'll assume this is the lighthouse. And I don't know. I'm not sure what else to label. We know that the whole tower would go all the way from the ground up to here, so that's the 84. Then we know that the angle of elevation is 58, that's this angle here. Alright. So far, how far is he standing from base lighthouse? Okay, so this blue segment is what we have to solve for. We'll call that X. Let's not forget that they told us that Casey is 6 feet tall. That means that if all of this angle of elevation stuff is happening up at the top, then that's 6 feet that we can take away from the 84. So these lunches only have to be... What am I talking about? So this segment here, this part of the lighthouse, sorry. This part of the lighthouse. It wouldn't be the full 84 because we're losing the 6 feet here that the dude stands up 6 feet tall. So take 6 away from 84, you're left with only 78. Oy, but after all that rigmarole, we've got our little right triangle. I'm going to pull it out off to the side, label the important parts. We know that the angle of elevation was 58. We know that the opposite side now is really just kind of 78, and we know we're solving for that. So this is looking a heck of a lot like a tangent equation to me. So we'll do the tangent of 58, set it equal to 78 over x. So x then is going to equal 78 divided by tangent of 58, which equals 1.34. Is that real? Doesn't feel right. No, not at all right. I forgot the tangent. Okay, so 78 divided by tangent 58. That's much better. 48.74. Whoops. And if Casey is 6 feet tall, then these must also be feet. And that's it for Casey. Let's do number 3. Alright, number 3 says Leah's mom is standing at the bottom of a slide at a playground waiting for Leah to slide down. If the angle of elevation from the bottom of the slide to the top is 46 degrees and the slide has a vertical height of 9, then find the length of the slide. No problem. Here's my slide. Boop. Here's the vertical height of my slide. Here's the horizontal base of my slide. So reading through, it says the angle of elevation is 46. That's this angle right here, because that's the angle that rotated up towards something. It says the slide has a vertical height of 9 feet. That's this. That's 9 feet. And they want to know, find the length of the slide. So the length of the slide is the hypotenuse. And we can do this pretty easily. We've got 9, which is opposite from 46, and we have x, which is the hypotenuse. So we'll say sine of 46 equals 9 over x. Yeah. Which means if you cross multiply, you get x times the sine of 46, but then you have to divide by the sine of 46. So x is going to end up equaling 9 divided by sine of 46. And that is approximately 12.51. And that's feet. Everything's feet. That's not true. We saw meters a couple of times. All right, that's 3. How's 5 looking? So 5 is where you start talking about angle of depression, but it doesn't really change much. So this one said a lifeguard is sitting on a platform. So here's your lifeguard. Boop. He's sitting up here on this chair. It says the lifeguard's line of sight is 8 feet above the ground. So tick, 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 tick. That's the horizontal line that we're just going to measure our angle against. But it says the angle of depression out to a swimmer is 18 degrees. 18 degrees is pretty small. So this person's going to be pretty far out of the water. But that's 18 degrees. 8 feet above the ground. So our little sight line deal tells us that this height is 8. And I guess that's it. It says how far away is the swimmer from the lifeguard? And so I don't know what they mean by that. There's some ambiguity. Would you measure distance from the actual lifeguard, just chilling up here in his chair? Would you measure the distance diagonally to the swimmer? Look at him swimming. He's doing such a good job. If you think that the distance should be from the lifeguard directly down to the swimmer, then you would solve for x. I think they might mean, though, what's the distance across the beach, like from the base of the lighthouse to the boy swimming. And honestly, I don't care which way you do it, because they're both useful. So I'm going to stick with my interpretation, which is that we want this dimension that's down here on the ground. So I won't do x. But to solve these, we solve them the same way. You've got an 18-degree angle up here, which feels weird, because that 18 is not even part of our triangle. But it only feels weird for about a second, and then you remember that this 18-degree angle is congruent to this 18-degree angle down here. And that's because this horizontal sight line is parallel to the horizontal ground. These are parallel lines cut by a transversal. So these are alternate interior angles that must be congruent. So we can use the 18, and opposite from the 18 is 8, and adjacent to 18 is y. So I can solve. Opposite over adjacent is going to be tangent. So tangent of 18 equals 8 over y. Sure. Multiply by y, it moves over to here. Divide by tan, and you get y equals 8 divided by tangent of 18. And I'll come back to that if I have to. Well, I'll come back to it now because we got to actually eyeball this. So what is it? It's 8 divided by tan 18. So 24.62. Okay, moving on to 7. So what is this? Building A is 480 feet tall. Pew, pew, pew. Building B is 654 feet tall, so that's the taller one. Pew, pew, pew. The angle of depression from the top of building B to the top, from the top of building B to the top of, alright, so we're going from top to top. And they said angle of depression, yeah. So angle of depression means I should have made a nice horizontal line like this, and then my angle should have rotated down from there, giving us 42. But what we're trying to solve for is how far apart are the two buildings. I'm going to call that D for distance. And of course the distance between the two buildings, you could measure it up here. Assuming the buildings are parallel, which they are. But that's D. And what else did we have? We didn't solve for anything else. Oh, we have the height of the buildings, of course. So this short guy is 480. And this big boy is 654. Well, if this is 480, then this piece over here is 480. So we know that this leg right here, this vertical leg of this triangle, is just the 654 minus 480. Which is what? 274. I'm going to go ahead and check that calculation because I'm feeling pretty tired. I don't feel like messing up. So 654 minus. Ay, ay, ay. Yeah, that's what I want. 480. 174. How did I get that wrong? Alright, I'm glad I double checked. It's 174. So that means I can now do this problem because I just keep my eyes focused on just this green triangle. And we know this is a right angle. We know that we didn't get our angle yet, really. We've got this 42-degree angle, but we would use alternate interior angles to bump that angle down here. And we know we can do that because angles of depression are always equal to the angle of elevation, where they're sort of on the same transversal. You can count that those are the same. So from this 42, we can say that 174 is opposite. And we're solving for this other leg down here, not the hypotenuse. So we're solving for that. So this is technically another opposite over adjacent. That means tangent. And our angle was 42. And our fraction is 174 over D. Alright, so multiply both sides by D. D moves over here, cancels out over here. Then divide by tangent of 42, and you get a D that equals 174 divided by tangent of 42. And that's it. You could technically stop there if you wanted to, or you could just type that into your calculator and turn it into a decimal. So let's do that. 174 divided by 1042. 193.25. Okay, what about 9? There is no 9. Great, we're done. So that's the last of your homework. That was page 142. If you need to study more, there's a video of the review packet. There's a Delta Math assignment. There's a lot you could do to try to prepare. So I hope when I see you again on Monday, you're ready to go. Goodbye.